Mr. Oakwood. We're part of the team that's been assembled to work with the Wolf to get your spaceship with the G-Man to the moon, and we've come to brief you on that. Alright, let's go ahead and hear what you have to say about all this. Well, we brought some visual aids to help, and let's take a look at this. If you look right here at the top right hand corner, it shows Barnard's star in 2020. Now that's Earth years 2020. We don't use their calendar. It's like their gravity. It's fake religion. We use a real calendar. We go by tree rings. Now, if you look, you see up here at Barnard's star on the top right hand corner, it shows a distance of 11 light years to Aries. But if you notice, just above Aries here at the bottom left hand corner, you have your 4.1 light years to Alpha Centauri. And just above that you have your 3.1 light years up here at Barnard's star in the year 3084. So you see, if we just hang out for a little bit, we'll be 3.1 light years in Earth year 3084, and we'll be able to send the G-Man, and he'll get there a whole lot quicker, and we have less problems with black bodies or anything else that might affect the travel. Now, the travel from Tree Planet, let me zoom in on this so you can get a better look at it right here. The travel from Tree Planet to Earth in flight time years, okay, from 2020 to Aries, from Tree Planet to Aries, is 84,000 times 10 to the 12th power years. That's a lot of years. G-Man might have actually turned to stone by then. Of course, there's not going to be any minerals in the spaceship except the spaceship. But if we wait until 3084, the year 3084 on Earth, to launch the G-Man, it will only take 47,000 years for him to reach that. He'd still be alive. Guaranteed he'd still be alive. Isn't it your purpose to make him be all alone? Well, my reason for sending him to the moon is just to give him that desperate, hopeless feeling. Well, he'll certainly have that, and the Wolf has got some more cards for you to look at, and I'll put one up and we'll show you what that looks like. If you look at this is Barnard's star here, and it's a projected interstellar G-Man capsule path. He would be traveling across like so, and then he would intercept Aries as it comes up to meet him. Now, as you know, the spiral arm of the galaxy that we're all in is moving upwards towards Andromeda at about 60 miles per second. So we have to project where Aries will be based on the speed of the spacecraft. And these calculations are all pretty, they're pretty dicey at this time. Because again, we haven't gotten the information from the Greys that we sent the Foxes to get, although they've gotten some of it. The transit time is 1 billion quadrillion years. That's a lot of time for the G-Man to be in that capsule all by himself. He'll have plenty of time to think about working for criminals in elected office. In this visual, you see the Earth right down here, 93 million miles to Aries, and it's 250,000 miles to the moon. Now, if you look right over here, if you look at this, in 2012, shows the moon, the Earth is still 91 million miles away. However, as you move forward in time, here's your Aries, here's your moon in 84,000 miles. It's way out here. It is tremendously moved out because it's moving at the rate of about 1 to 1.5 inches per year as it moves away from the Earth, which means it's going to be nowhere close to the Earth in that year. That means there won't be any tides, and lovers won't be promising their beloved the moon. and that'll be a good thing for real estate value. How many more of these cards are y'all going to post? Mr. Oakwood will post as many as you need to make it clear that we should wait until 3084 to launch the Gman to the moon. I don't want to wait till 3084, and it doesn't matter to me if he's in space for whatever that huge number was you gave a minute ago. Let's look at this one, see where we're going. Alright, as you see, Barnard Star, the projected path for the Gman interstellar transit, will be across like that. We have a pretty good idea that there's minimal black bodies out in space. That's going to be your planets, rock debris, stuff like that, which would affect the flight path due to curved space. You have Aries over here, it would be moving towards the top of the YouTube watcher's screen. Or if you're not on YouTube, it'd be moving towards the top of your television screen. Of course, if you're not watching this on television, it would be moving towards the top of your computer screen. Enough of this. Enough. Mr. Oakwood, we're just trying to cover all the possibilities. You know about PC, personal computer, political correctness. Mr. Oakwood, we have one more visual that we want to show you. I sure hope it's only one more visual. It is, sir. It is. It comes on 2 cards, but it's one visual. Oh, good grief. To think these people are being paid for this. Alright, if you look at this, it shows current 2020. That's Earth years, because they don't use tree rings for their dates. And then we have 3024, the projected date that we would, or 3084, the projected date that we'd be needing to launch the capsule. But let's look down here at the bottom, because this is more interesting. See down here we have these various numbers and things. I see the various numbers and things. Just get on with this. You're really biting into my coffee time. Alright, you look at the Earth Moon. From Earth to Aries, it's 93 million miles. From the Earth to the Moon, it's 250,000 miles. But in 3084, the Earth to Aries is still about 93 million miles. But the Earth to the Moon is 300,000 miles, and we have to compensate for that and fire our rocket off to intercept the moon where it should be in that time period. Herein is our problem, and that is that we don't have good tables for where the moon might be during that transiting time, because its orbital shift, its apogee and perigee, is going to change massively. So to conclude, we have our little graphic here of Aries and the planets around it. And we have the 4.3 light years to Alpha Centauri, and we'll have the 3.1 light years to Barnard Star in 3084. Somebody wrote a 64 on there, but just ignore that. It's probably just a prankster. Whereas right now we're sitting at 11.1 light years. I just looked up the distance to Barnard Star while y'all were giving that presentation on my computer, and it says Barnard Star is not that far away. Well, sir, it depends on the astronomy book and what year it was written. As time goes by, things become more and more accurate. Then why are you not using the revised stuff instead of going with 11.1 light years? Well, sir, we were hoping some of the YouTube people might actually do a little research on their own and find something out. You expect somebody who watches a video on YouTube to actually research something? Well,